Let's review some trig identities that you already know. Let's start with the Pythagorean identities. These identities came out of the Pythagoras theorem. The first one is that the square of the sine of x plus the square of cosine of x is equal to 1. Let me get my highlighter. Put this so I can point to this. Yeah, this. All right. Sine squared x plus cosine squared x is equal to 1. All right. And tangent squared x plus 1 is equal to secant squared x. I'm sure you've seen this before. Cotangent squared x plus 1 is equal to cosecant squared x. All right. Now, we also have the double angle formulas. These are called the double angle formulas because they're usually written as cosine 2x. They're expressed in terms of 2 times x. All right. So, but the part or the version we're going to be using is for expressing cosine squared x and sine squared x. So cosine squared x is equal to 1/2 times 1 plus cosine of 2x, and sine squared x is equal to 1/2 times 1 minus cosine of 2x. These are trig identities that you probably saw in pre-calculus or in high school, but they're going to be very important for the kind of integration we're going to do in this section. All right, so these are called trigonometric integrals, or just trig integrals. This is from, I believe, section 8.3 of your textbook. All right. Let's start with integrals involving sine and cosine. So assume you want to integrate an integral that has the form sine mx, sine of x to the power of m, and then cosine of x to the power of n x dx. Okay, so the powers of sine and cosine are m and n respectively. So it's important to point out that in this case where m and n, they're integers. All right, there's a little rule here. The rule is this. Rule A, if m is odd, so if the power of sine is odd, factor out a sine x, factor out a sine x. Okay, that's the first thing you do. Rewrite the remainder or the remaining terms in terms, that sounds wrong, but that's all I got now. In terms of cosine of x, and then finish solving. Employ U substitution, and you finish it. All right. If m is odd, factor out the sine of x, rewrite the remaining terms in terms of cosine x, employ U substitution. Now, you can imagine now, if n is odd, you do something similar. If n is odd, so if the power of cosine is odd, you want to factor out a cosine x. You want to rewrite the remaining terms. In terms of sine x, and then you want to employ U substitution to finish solving. So I want to point out that whatever you factor out, you got to save it. So when you factor out a sine x here, save it. Don't do anything to it because it's going to help you with your U substitution. And when you factor out a cosine s here, save it. And because you will end up using it for U substitution. It won't be your U. You can't make it your U. All right. Now, how about if both are even, if both m and n are even, this is not a good situation because it becomes a little bit too tedious to solve. Use the half angle formula. No, I think I called it a double angle formula. Yeah, use the double angle formula. To get rid of exponents. Okay, and then finish it. All right, so we're going to do some examples, and those examples are going to really make use of this trig identity. We're going to make use of this trig identity right here. Sine squared x plus cosine squared x is equal to 1. Example 1. Want to find the integral of sine squared x cosine cube x dx. Okay. So in this case, I want to write this a little larger than this because I realize that I've been writing very tiny in the previous videos. Integral sine, maybe if I make it bigger, I can write it a little larger. Integral sine squared x cosine cube x dx. Okay. All right. So if you look at here, the power of cosine is odd. So we have to factor out a cosine of x. So that means we have sine x squared or sine squared x, and then cosine squared x, and then cosine of x dx. We are going to save this cosine of x. And I want to do something. I want to write, instead of writing it as sine squared x, I want to write it as sine x squared. And then I want to write this as cosine x squared, okay? Like that. All right. It doesn't matter. Why not? Why belabor the point? No, it doesn't really matter. It doesn't matter. It doesn't add anything to our thinking. But this is what we have. So what we do now is we rewrite the remaining terms in terms of sine x. So the first term is already in terms of sine x, so we have sine squared x. And then cosine x, if you remember, you see that sine x, right here, sine x plus sine squared x plus cosine squared x is equal to 1. So that means that cosine squared x can be written as 1 minus sine squared x. So the cosine squared x, write it as 1 minus sine squared x. And we still save this cosine x here, dx. Save it. Don't do anything to it. Now, what you now do is you can now see that you have something that can be worked on using substitution. Use substitution. So expand sine squared x minus sine to the fourth x, and then the cosine x that is saved, that you saved. All right, now do your u substitution. Your u has to be sine of x, because the whole point of factoring out the cosine of x is so that it will help you with your u substitution, to help you cancel something out. All right, so if you say let u be sine x, let u equal to sine x, then du dx is equal to cosine x. Then du dx is equal to cosine x. Then du is equal to cosine x dx. Okay, so this makes our problem a little easier, because what do you see now? This becomes u squared minus u to the fourth, and then cosine of x dx is now just equal to du. Everything is in terms of u, so you're good to go. Now do the integral. U to the power of 4, u squared, if you integrate, you get u cubed over 3 minus u to the power of 5 over 5 plus c. So if you do that, that means your final answer in terms of x becomes sine cube x over 3 minus sine fifth x over 5 plus c. So that's your final answer. Okay? All right, I want you to try one. Try this one. Just cosine cube of x dx. Just cosine. So here, let me start it out for you. You get cosine squared x, cosine of x. You save cosine of x dx. And then you let u, if you let u be cosine of x, actually no, we're not there yet. We're not there yet. So you saved one of your cosine, you have to rewrite every other thing in terms of sine. So this becomes 1 minus sine squared x. And then you have the cosine of x that you saved. So I want you to finish this up. I want you to pause and finish it up. Don't look at the answer. Come back and look at this answer that I'm going to write down. Pause. Are you paused? You shouldn't be looking at my answer. All right. Are you back? The answer should be sine x minus 1/3 sine cube x plus c. At least that's what I got. Check me, check my answer, and tell me in class if it's right or wrong. Okay? You need U substitution. My hint is that you needed U substitution. Your U should be sine of x. That's the hint. All right, let's keep going. How about we try integral let's do sine squared x dx. How about that? Okay, integral sine squared x dx. So we don't have any odd power of sine or cosine. So what we can do is we can go ahead and use the double angle formula. So remember that sine squared x is 1/2 times 1 minus cosine 2x. All right. So we can write this as the integral of 1/2 1 minus cosine 2x dx. Automatically, already we can factor out the 1/2 because it's a constant, and constants, very nice things. We can play with them however we want. All right, we have 1 minus cosine 2x dx. All right, so we can easily integrate this. So we have 1/2, and then integral of 1 is just x. Integral of cosine x is sine x. So the integral of cosine 2x is 1/2 cosine of 2x. You can check that using U substitution. Make U equals 2x. You see that this is the answer you get. Sine of 2x, sorry. And then plus c. All right. Now I want you to try another one. Well, let's do it together. This is the integral of sine cube x cosine to the power of negative 2x dx. If you look at this, sine has the power, the odd power, so we can factor out the sine. So this is the integral of sine squared x cosine to the power of negative 2x, and then sine of x dx. So we can rewrite everything as in terms of cosine. Everything should be rewritten in terms of cosine. Why? Because we factor out a sine, and this is going to help us with our u. So if you rewrite everything in terms of sine, you have, in terms of cosine, you have 1 minus cosine squared x. All right. So the sine squared x is 1 minus cosine squared x, and then times cosine to the power of negative 2x. And then you have your sine x, then you have your dx. All right, so this becomes integral cosine to the power of negative 2x. And then cosine squared x times cosine to the power of negative 2x becomes just negative 1. All right. And then you still have your sine x dx. So u substitution can help us now. Let's let our u be cosine of x. In that case, du dx is negative sine of x, and that means that that du or dx, actually let's solve for du, so that du is equal to negative sine of x dx. So we go in here, this is integral u to the power of negative 2 minus 1 times du. So u to the power of negative 2, if you find the integral, is negative u to the power of negative 1, which we can write as, I'm going to write it as negative 1 over u minus u plus c. So we just have our u is cosine, so negative 1 over u is secant, negative secant of x, minus cosine of x, plus cosine of x. Minus and cosine and plus. Something wasn't working. Something is wrong. I screwed up. Sorry about that. So the sine of x here was there's a negative, but I didn't include the negative. So let's put the negative right there. So the negative, we can bring it out right here, and that's going to change. That's going to change this to plus, and that keeps this as, it's going to change a few things. So we had negative. All right, let me explain what I'm saying. I like this. I like that I made a mistake because I can use it to explain. So this is negative sine x. So I put the sine x here and put the negative outside, okay? All right, so if I'm still going to maintain the negative outside here, and u to the power of negative 2, if you find the integral, you get negative u to the power of negative 1, and you multiply by negative, you just get negative, or you get positive. And here you have u 1, and you take the integral, is just u, so you get positive also, positive. All right, so this is just secant of x plus cosine of x plus c. So that's your solution. Okay. All right, I'm going to make this short. I'm going to do another video involving tangent and cotangent and cosecant. Yes. So we'll stop here for now.